Good morning, everybody. I hope everyone is staying warm and had a good day yesterday. Today's lesson's not super long. It's just the last thing we need to cover on 4.6. Yesterday we talked about Tuesday we talked about the fundamental theorem of algebra. Today we're going to talk about something a little different. It kind of ties into it a little bit, but hopefully it goes quick. The thing we're talking about is Descartes' rule of signs. So there's this French mathematician named René Descartes, and he found the following relationship between the coefficients of a polynomial function and the number of positive and negative zeros of the function. So here is the actual rule, Descartes' rule of signs. So it says let f of x equal a sub n x to the n power plus a sub n minus 1 x to the n minus 1 plus plus a sub 2 x squared plus a sub 1 x plus a sub 0 be a polynomial function with real coefficients. So it's just representing a polynomial function with real coefficients. The number of positive real zeros of f is equal to the number of changes in sign of the coefficients of f of x, or is less than this by an even number. Also, the number of negative real zeros of f is equal to the number of changes in the sign of the coefficients of f of negative x, or is less than this by an even number. So, we know how many zeros total there are based on the degree of our polynomial function. That was what the fundamental of algebra was telling us on Tuesday. Descartes' rule of signs kind of breaks it down though, and we can kind of get the exact number of positive real zeros and the number of negative real zeros. So let's look at our example for today. It says determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros for f of x equals x to the 6th minus 2x to the 5th plus 3x to the 4th minus 10x cubed minus 6x squared minus 8x minus 8. That's a lot. We're not really worried about the polynomial when we're talking about Descartes' rule of signs, though. We're just looking at all of the signs in front of all of our coefficients, including this first one. So this first one has a positive 1. So I just want to see throughout my polynomial how many times my sign changes. So the first sign is positive, the next one is negative. So that would be one sign change right there. So the second one's negative, the third one is positive. So that would be another sign change. Third one's positive, fourth one is negative. That's another sign change. The rest of them from there on out are all negative, so that's all the sign changes I have for my polynomial function. So the coefficients in my f of x have 3 sign changes. So the possibilities of positive real zeros are 3, but from Descartes' rule of signs, or is less than this by an even number. So if I subtract 2 from 3, that would be 1. So the possible number of positive real zeros would be 3 or 1. Because there's 3 sign changes. Now, the number of negative real zeros of f is equal to the number of changes in the sign of the coefficients of f of negative x. So I hope we all remember how to find f of negative x. I would just replace my x values with the negative x. So I'd get negative x to the 6th minus 2 times negative x to the 5th plus 3 times negative x to the 4th minus 10 times negative x to the 3rd. I'm running out of room. Minus 6 times negative x squared minus 8 times negative x minus 8. So now I just need to evaluate all of these. So f of negative x would be negative x to the 6th power would be negative x times 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 negative x. That would come out to be x to the 6th, positive x to the 6th. And then my negative 2 times negative x to the 6th would be negative 2 times negative x to the 5th, which would become positive 2x to the 5th, plus 3x to the 4th, plus 10x cubed, minus 6x squared, plus 8x minus 8. So this function at the bottom is f of negative x. So to find the possible number of negative real zeros, I need to count the sign changes in f of negative x. So once again, I have a positive there. So between the first two, I don't have a sign change. Between 2 and 3, I don't have a sign change. Between 3 and 4, no sign change. But from here to here, I've got a sign change. From here to the next one, I also have a sign change. And then between the last two, I have another sign change. So for f of negative x, I have 3 sign changes. So once again, the number of negative real zeros of f is equal to the number of changes in the sign of the coefficients of f of negative x, or is less than by an even number. So since there's 3 sign changes in f of negative x, the possible number of negative real zeros is 3 or 1, once again. Now notice it says imaginary zeros as well. So here's what we're going to do. We're going to create a chart that lists all the possible outcomes of positive real zeros, negative real zeros, and imaginary zeros. Now if you remember from our fundamental theorem of algebra yesterday, the total number of zeros that this polynomial has is 6, because that's the degree of my polynomial. So I need to keep that in mind as I'm creating my chart as well. So I'm going to create my chart. Positive real zeros. Negative real zeros. Imaginary zeros. And total zeros. So my total number of zeros in each of these columns is going to be 6, because that's how many zeros I have total. Now let's start with us having 3 positive real zeros and 3 negative real zeros, because I had 3 sign changes on my function and 3 sign changes on f of negative x. So if I have 3 positive real zeros, 3 negative real zeros, and I want 6 total zeros, that would mean I would have 0 imaginary zeros for that outcome. So there's one possible outcome. Now let's say we had 3 real zeros, and then we said we had 1 negative real zero. If I have 3 positive real, 1 negative real, that would mean I would have 2 imaginary zeros, because I want a total of 6. Now another one of our outcomes for positive real zeros was 1 and 3 negative real zeros. So if I have 1 positive real 0, 3 negative real zeros, I would once again have 2 imaginary zeros for a total of 6. So as you can see, I'm just writing all the possible combinations from what I got based on Descartes' rule of signs. So another possible outcome would be me having 1 positive real 0, 1 negative real 0. So that would mean I would have 4 imaginary zeros for a total of 6. And that's all my possible outcomes based on Descartes' rule of signs. I could have 3 positive, 3 negative, 0 imaginary, 3 positive real, 1 negative real, 2 imaginary, 1 positive real, 3 negative real, 2 imaginary, or 1 positive real, 1 negative real, and 4 imaginary zeros. This just tells me, like I said, all my possible outcomes of my types of zeros. It doesn't actually give us our zeros. We would have to use rational root theorem and synthetic division and all our other methods to find the actual zeros, but this gives us a good idea of the numbers of zeros and types of zeros we might have. So that's all I have for us today. So our assignment for today is page 211, numbers 33 through 42 all. It's just doing like what we did on this example right here. You're looking at the sign changes for f of x for our positive real zeros. You're looking at the sign changes on f of negative x for the negative real zeros. And you're creating charts on all of them like we did on this example right here. So if you have any questions or you don't understand this, please make sure you're asking me and we'll try to get it figured out for you guys. Let's say this is due, let's see, we've got that big assignment due tomorrow. So we'll have this due on Monday, which is February 15th on Canvas. Once again, let me know if you have any questions. I'd be happy to try to help you guys understand it a little better. Hope you guys have a good rest of your day, and we'll see you next time.